A really good plot to describe quantitative data is to use the box plot. Now here I have the earthquake data associated with tsunamis, and we're going to graph them using the box plot. Here it is. We have one simple set of data. Give it the data we're interested in, click OK, let Minitab do its own thing, and here's what I end up with. Now if I mouse over the box itself, let's see, it gives me some summary information on this data set. Number one, whoops, if I move it. Number one, it tells me that there are 1,293 data points, so nearly 1,300 data points in this data set. The Q1 and Q3 are given, as well as the median. And what these numbers tell me is where 50% or the middle 50% of these data lie. So first of all, the middle number is 7.1. So 7.1 is the data value that fits midway between largest and smallest. Q1 represents the 25th percentile, that's the bottom of the box. Q3 is the 75th percentile, it represents the top of the box. So really 50% of these numbers, and that's nearly 600 of them, fall between 6.6 and 7.6. So that's only 1 Richter unit in length. So I've got a pretty small spread of data from Q1 to Q3, but overall the data set, if I look at the overall range, they run from a high of 9.5 to a low of 3.2. So the overall data set is fairly variable, but the bulk of the data are pretty closely clustered together in the center, ranging from 6.6 to 7.6, with the center of 7.1. These data, if I look at just the center of the data are very symmetric, but if I have to look at the entire data set from the largest to the smallest, because there are quite a large number here of small outliers, most likely if I look at a histogram, I'm going to find that these data overall are going to look like they have a left skew. And let's just have a look at that. If we go to graph, histogram, simple histogram, do the magnitude, and here's my histogram of these data, whoops, and I can see that in the center, yeah, they do pretty much look like a bell, but there's a long tail to the left, and that long tail to the left is because of this large number of small outliers that we have in this data set. The advantage a box plot has over a histogram is that there's only one way to draw a box plot. What you see is what you get. On histograms, as we've already seen, you can go in and you can change the number of bins. So right here, if I double click, I can choose binning. It's using 32. You might decide you want to use, so I don't know, 24 or whatever. So the shape of a histogram can change depending on the number of bins you use or your interval size, whereas a box plot, those 5 numbers, max, min, the median, Q1 and Q3, are what they are, and you can't change that. And that can be an advantage because there's no way to manipulate the data graphically.